Hello and welcome to Lesson 12 for Math 13X. This is about binomial probabilities. And although you could use the binomial formula, I'm going to use the calculator instead. So, first of all, we need to write down what the probability of success for a single person is. So that is denoted a lowercase p, and also change this to decimal form. So move the decimal 2 places to the left, which means that it's going to be a 0.096. So 9.6% of people are left-handed in the United States. And then this is the n, so n equals 8. All right, then to the question. So out of the 8 people, find the probability exactly 2 of them are left-handed. So it's asking for the probability that x equals 2 of them. And like I said, I'm not going to use the formula, I'm going to use the calculator. And if you haven't done that before, it's in a slightly different place. It's over here where it says distr, which stands for distributions. So go to second distributions and then look for binomial. So that is down here. And there's actually 2 of them that say binomial. There's the binomial PDF, and then the P stands for when you have an equal sign. And the C stands for if you have a less than or equal. So the C goes with less than or equal, and the binomial PDF goes for when you've got an equals. So I'm using this one, A. The number of trials, that means what does n equal? 8. The P is 0.096, and then the x value is 2. And then it will put that on the screen and give you the answer. And what I ask my students to do, since we're using the calculator, is write down what you did. So I used binomial PDF with an 8 and then a 0.096 and then x equals 2. So the chances that exactly 2 of those people are left-handed is about 14.1%. And you could either leave it as the decimal or you could write it as 14.1%. All right, on to the next one. So the setup here is all the same. I'm still going to use this information. So I'm still using P equals the 0.096 and n equals 8. And then this one is saying x is fewer than 2. So fewer does not actually include 2. So that actually means that it is less than or equal to 1 person. So basically you could have none of the people are left-handed, maybe 1 person or 2 persons or 3 or 4, or maybe all 8 are left-handed. And with it saying fewer than 2, it's saying do not include the 2, but it's less than or equal to 1. And then there's 2 ways to do this problem. One is you could use the binomial formula that I just used, put a 1 here, and then also put a 0 here, and then add the 2 answers together. So if you do that, and by the way, once you do the binomial formula, you could just move the cursor up and grab it, and then back up and put a 1. And then back up and put a 0. So this is one way to do it. And I need to just switch over to show my work. And so I have the binomial PDF with an 8, a 0.096, and a 1. And then, let me just copy and paste this on the paper real fast. the old-fashioned way. And then make this a 0. So I'm basically doing these two cases. And then for this one, I got a 0.397. Excuse me, I said it wrong. 379. And for the second one, I got a 0.446. And then just add these two answers together. So then a 0.379 plus a 0.446, and then that equals 0.825. Now let me show you a slightly different way to do it. So like I said, when it's a less than or equal, then you can use the binomial CDF, and it will basically add these up for you. So I could have also done second distribution and then go down to the binomial CDF. The n is 8, the p is 0.096, and then the x value is 1. And because of that c right there, that actually means the less than or equal to 1. So then paste that and get the answer, and it's the exact same thing. So this one, because it was only 2 decimals that I had to add up, wasn't too bad. But if there's ever a case where you're going to have to add up like 9 of these, then it's easier to use the binomial CDF. All right, then a couple more examples, and it's still using the left-handed people idea. Find the probability at least one of them. Okay, so I still have that the p equals 0.096, that n equals 8. And then find the probability of at least one of them. So like I said just a moment ago, it could be none of them are left-handed, or 1, or 2, or 3, or 4, 5, 6, 7, or maybe all 8 people are left-handed. And what this is saying, with at least one, that means start at 1 and do the binomial formula for all of these, and then add up all of those 8 decimals. Well, that would take a lot of work. So there is a faster way to do it. And what you do is you do the opposite of what's asked for. So I asked for 1 through 8. Instead, you do the binomial formula for 0. And since the total has to be 100%, then whatever we get, we'll just subtract from 100%, and that's going to be this side. So another way to say that is 1 minus. So this represents the 100%, but we're using decimals, so I'm not going to write the 100%, just put it in decimal form, which is 1. And then minus, and now do the binomial formula. And I'm going to use the PDF because I only need when it equals 0. And then put the 8 and the 0.096, and then the 0. And instead of us having to do it 8 times and add them all up, it just gives us the answer right away. So don't forget to put the 1 minus in the calculator. And then go back to distributions and go to the binomial PDF. This is an 8. P is a 0.096. And the x value is 0. And the chances that you have at least one left-handed person is 0.554. So I was looking at that number. You might have noticed that I paused because I thought this was going to be bigger, the chances of having at least one. But if you look at this part, the chances of 0 is 446. And if you do 1 minus 0.446, it equals the 554. So that means that 0.554 is correct. Okay, then for the last part. So this part goes pretty fast. So with a binomial situation, the mean is just n times p. And the standard deviation is the square root of n times p, and then 1 minus p. So that means that the mean is going to be n, which is 8, times the p 0.096. So an 8 times 0.096, so that equals 0.768, which basically means if you have 8 people, how many do you think are going to be left-handed? So most likely a little bit less than one of them will be left-handed, which basically means if you get one group of 8, another group of 8, another group of 8, another group of 8, and you keep finding how many left-handed people are in each group and you average it, it's going to be this many people. Then for the standard deviation, so that's going to be, I might need a little more room, the square root, and it starts off the same, the n times the p, and then 1 minus the p. So basically, if this is the percent that are left-handed, this is the percent that are right-handed. And then take the square root of that whole thing. So we haven't done square root for a little while. Remember, it's over here. You need to put second square root, and then basically type it in exactly as it looks. So then 8 parentheses 0.096, and then parenthesis close and parenthesis open, 1 minus 0.096, and the square root is going across the whole thing just like it's supposed to. And it turns out that the standard deviation is 0.833. So there's the mean, and there's the standard deviation.